So, gravity's the referee, right? Phone drops, it hits the floor. No argument. But last week, the same models that landed Perseverance inside a crater on Mars started flashing red because the third interstellar visitor we've ever seen, 3I/ATLAS, just flicked its trajectory by a distance that sounds tiny until you realize it's 30 times bigger than the wiggle we budget for when a comet burps. 30 times. The maths we've used since Halley's homecoming in 1759 just bounced. Today, we're walking through every sane, half-sane, and hold-my-telescope idea for why a tourist from another star is ghosting the rulebook, and why October 2025 might hand us the weirdest dataset in comet history. Same robotic survey in Hawaii that scours for city-killer asteroids found this thing. The 3 eyes just means interstellar object number 3. Orbit's so hyperbolic, the sun barely manages a handshake before slingshotting it back to the dark. Speed? 60 kilometers every second. Cross the continental US in under 2 minutes. Retrograde, and only 5 degrees off the plane the planets use. Picture a race car driver who decides to barrel the wrong way down the motorway, yet hugs the yellow line. End of October, it slips between Earth and Mars, close enough that a 6-inch scope under dark skies can say hello. Zero impact risk, front row seat to whatever stunt it pulls next. Dirty snowball, heat hits, ices flash to gas, balloon escapes, tiny thruster nudge, textbook since 1950. Rosetta watched 67P get shoved around by exactly this. You add the jets to gravity, you predict the path. Every flyby since Giotto met Halley says, works for us. Until now. For 3I/ATLAS, the jet we can measure from its gas, and dust is only 3% of the push we actually see. Gravity alone? Not enough. The thruster? Not enough. Together? Still not enough. Something else is leaning on the steering wheel. 4 continents, 9 months, hundreds of plates exposed. Chile's Very Large Telescope caught cyanide puffing out like a 2-kilometer nucleus exhaling. Yet the spectra show almost zero water, tons of CO2 ice, no neat fire hose jets. CO2 makes a lazy sigh, not a rocket plume. Meanwhile, the thing's sky track drifts outward, 0.7 arcseconds per day, more than the spreadsheet says. Compound that, and you're looking at 2 centimeters per second of bonus speed every single hour. Over months, that's thousands of kilometers of extra travel. Error bars? Now smaller than the effect. The signal is real, and it is laughing at us. Fragmenting comets recoil like a shotgun. Hubble looked. No mini-nuclei, no wings of debris, no anomalous brightening. Core looks steady. So unless it cracked into perfectly mirrored halves that decided to cosplay as one object, cosmic coin trick, this explanation fizzles. Spitzer's infrared view? No temperature spike that goes with fresh ice. The comet is intact, and weirdly polite about it. Radiation pressure is tiny but relentless. It shoved Japan's Ikaros sail. For that to matter here, 3I/ATLAS would need the density of a meringue, under 0.01 grams per cubic centimeter. A fluffball that light should have crumbled under spin or tides ages ago. And we're not seeing brightness oscillations that scream rotating tumbleweed. Density from gas production sits around styrofoam level, still too heavy for sunlight to bully this hard. October 14th, it skims 0.05 astronomical units from Mars, 20 Earth-Moon distances. Too far for Martian tides, but close enough for MAVEN, ESA's trace gas orbiter, India's Mangalyaan, to taste any dust that slips past. If those probes register a sudden surge in fine particles, we'll know an unseen jet fired at the perfect vector. If they see nothing, the acceleration happened earlier, probably near perihelion when the heat peaked, tightening the timeline for any normal outgassing story. Harvard's Galileo project put out a preprint. Orbit's near-Koplaner alignment gives any interstellar craft a grand tour of the rocky planets at minimal fuel. Add the non-gravitational push, the lack of classic comet fingerprints, and the Bayesian needle twitches toward check for technology. Before eyebrows achieve escape velocity, remember, no repeating radio bursts from breakthrough. Listen, no infrared glow of solar panel farms. Hypothesis stays on the shelf labeled, keep an open mind, but demand data. Still, it's in peer-reviewed print, so we can talk about it without wearing tinfoil. JPL just stood up a rapid response non-grav working group. Think Apollo 13 mission control for comet maths. They're brute force simulating every heat pulse, dust shield, solar wind gust imaginable. Gaia is issuing fresh positions every 24 hours instead of monthly. Japan's Speculoos Southern Array is hunting outburst flashes. And the words, target of opportunity, are already whispered for the next sun-skimming probes. Nothing focuses rocket scientists like an equation that refuses to balance. Late September, it should touch magnitude 10. 6-inch scope, dark sky, done. It'll scoot through Cetus, then Pisces. Astrophotographers stack 10-second subs and you'll log the fuzzy glow, maybe a razor tail. Catch a sudden bright knot? Post the timestamp. Amateur data fed to the Minor Planet Center has saved missions before. Science is a team sport, and backyard eyes may be first to spot the next maneuver. If live cosmic detective stories light you up, the subscribe button is right there. Tap it, ring the bell, and YouTube will ping you the second we post updates on 3i/ATLAS, or whatever else, forgets how physics works. Oumuamua, Object 1, left with an extra kick but had zero coma. Debate stayed philosophical. 2i/Borisov, Object 2, behaved like a textbook comet. Now 3i/ATLAS merges the worst of both worlds. Visible activity, yet still off course. Pattern or coincidence? Sample size of 3. Statisticians wave their hands. Give us 10 more interlopers and we might learn our solar system is the weird one. Every time the universe ignores our homework, we get a free masterclass. The Pioneer anomaly taught us about heat reflecting off spacecraft surfaces. The flyby anomaly refined Earth's gravity maps. Now 3i/ATLAS could be pointing to gaps in comet geophysics, or new plasma interactions, or something we haven't named. The cosmos is under no obligation to make us comfortable, only to stay consistent within rules we're still writing. Once it rounds the sun and heads back into the void, the window for weirdness narrows. Solar heating fades. Any hidden volatiles freeze shut, locking the secret inside. Telescopes will chase another year, but the farther it gets, the fainter it becomes. October is our shot. If you want history to remember 2025 as the year humanity met a puzzle from another star and actually solved it, the clock is ticking louder every orbit. So here we stand. A silent chunk of someone else's solar system is threading the needle between our planets, politely ignoring the roadmap we printed. Maybe tomorrow a grad student spots the missing jet in an overlooked spectrum, and we all laugh at our panic. Or maybe we add a brand new line to the equations that guide our ships. Either way, 3i/ATLAS is reminding every one of us that the universe is still a place of surprises, and the biggest insult to science is pretending we've finished the textbook. Keep your eyes up, your telescopes ready, and your theories loose, because the next message from the stars might arrive as a comet that refuses to behave.